Okay, so for this lesson, we are performing similarity transformations, which means you're going to be doing dilations and finding the scale factor and reductions or enlargements, which are forms of dilations. So a dilation is a transformation that stretches or shrinks a figure. So that's kind of like the general vocab. Dilation means it moves. Think about your eye. Your eye dilates open and reduces. So it enlarges and reduces. So the two ways you dilate is a reduction, which makes it smaller, or an enlargement, which makes it bigger. You see they have two triangles here. And if I went from the blue triangle to the red triangle, that's considered an enlargement. If I start with the red triangle and go to the blue triangle, that would be considered a reduction. A figure is enlarged and reduced with respect to a fixed point, and that fixed point is always called the center of dilation, which is how you use the sides to find a ratio to find your scale factor of it enlarged by 2 or it reduced by 1/2 kind of things. Okay? And if you look here, this is the algebra you need right here. The original point, origin, and then it has the little transforms, that's what that arrow means, to the new point. And it's usually it multiplies by a whole number like 2 if it's an enlargement, or it multiplies by 1/2 if it's a reduction, or 1/3 or 1/4 or whatever it is. Okay? All right. So let's practice these. Example 1. So we're going to draw a dilation of a quadrilateral A, B, C, D with the vertices 2, 1. So this is A. B is 4, 1. C is 4, -1. And D is 1, -1. Okay, so the first thing it wants you to do is use the scale factor of 2. Scale factor is 2. Okay, so already this dilation, do you know whether it's a reduction or an enlargement? Right, you look at the scale factor to decide.
That's the enlargement.
Yes, if it's a whole number, if it's an enlargement, if it's a fraction, that's the reduction. All right, so we're going to graph this. So for A, go over 2 and up 1 and put a dot. I need a bigger dot. Over 2, up 1, and put a dot. Okay, so that's A. For B, we're going to go over 4 and up 1. For C, over 4, down 1. And D, over 1, down 1. Okay, and then you connect these lines to form our quadrilateral. Now remember, a quadrilateral just means it's got 4 sides. So it can be as straight as rectangles, but it can be funky shapes like this one. All right, so this is our original. And then what they want you to do is find the dilation. So I guess I should have written these points going vertical. So our first point, A, is 2, 1. Sorry, I'm going to rewrite these. Okay, and then we need to dilate these. We're going to give them new points, L, M, N, P, because we're creating a new quadrilateral. And the math they want you to do is to do what? Times 2. So it's like saying 2 times x, 2 times y is the new points. So our A value is 2 for the x, so that'd be, what's 2 times 2? So our new point is 4, and the other one is 1, so 2 times 1 would be 2. So that's our new point. So do it again. 4 times 2 is 8. 1 times 2 is? That's our next point. 4 times 2, 4 times -1, or 2 times -1. And the last one is 2 times 1, and 2 times -1. Very good. So now we just graph these 4 points. Make my dot bigger. So I'm going to go over 4 up 2. So there's my first point. Terrible point. Let me try that again. There we go. Then over 8. Whoops, my graph's not big enough. Up 2. I'll just pretend my graph is big enough. Over 8 down 2. And then over 2 down 2. All right, and then we connect. Hopefully you can draw a straighter line than I can. All right, and you'll notice it's in the same general shape. Of course, the picture out of the book is a lot nicer than my drawing. And it is definitely dilated and enlarged by the scale factor of 2. That's it. Any questions so far? Not too bad, right? Let's do example 2. So a triangle has the vertices. So I'm going to go ahead and write these vertices. A is 4, -4. B is 8, 2. And C is 8, -4. And what they want you to do is sketch triangle ABC and DEF, and then verify that they are similar. So to sketch these, we need the scale factor. What is our scale factor? 1/2. So already, do you know whether this is going to be a reduction or enlargement? Reduction, right, because it's a half. So it's going to be half as big as the original. So let's go ahead and do the math for these, and then we'll sketch them. So A, B, C, D, and then we'll just do E, F, G. Sure, why not? So what is 4 times a half? 2. -4 times a half? -2. Very good. 8 times 1/2?
4.
And then 2 times a half? 8 times a half again? -2 times a half. I meant -4. You heard me say the answer instead of the... I do that a lot. All right, so let's graph these. So let's do the first one. I need a bigger dot. So we're going to go over 4, down 4 for our first point. And then again over 8 and down 2. No, up 2. My graph is not big enough. I need to get a new graph. And then over 8 down 4. Okay, so here's our triangle chilling over here. Okay, all right, and let's graph the second one. We have over 2 down 2, over 4 down 1, over 4 down 2. I did something wrong, yes. Over 2 down 2, that's right. Over 4 up 1. See, I knew I was crazy. That's a positive one. There we go. That looks better. All right, so now does it look like a reduction? Yes. So you have to decide whether that was A. We sketched both of them. Good. For B, it says verify that triangle ABC and DEF are similar. Our similarity rules, we have to find either angle side, 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 angle, all of those, any of those. We know that we have a right angle, right?
Yeah.
This right here is a right angle. Ooh, moved the whole thing. This right here is a right angle. And this right here is a right angle. So already we have angles that, so then you just have to find proportions. So I can look at the distance here, because we don't want to find the distance, let me use my green marker. We don't want to find the distance of the hypotenuse, right? Because that involves using the distance formula. But we can do this compared to this, and we can do the straight edge compared to the straight edge. So if I do big triangle to little, I'm going 4 over 2, right? which reduces to what? Oh yeah, I said it backwards. You had it right. 2 over 1. Okay, and then I do the tall one, which is how tall? 6?
Yeah.
And how wide?
It's 3.
3. Which reduces to?
2.
So are these
Wait, no.
proportional?
Yeah.
Yeah. So according to side angle side, they are similar triangles. All right. Any questions? All right. Let's keep going. All right, I'm putting this whole thing in here so that you can see the pictures. Okay, so for example 3, we're going to find the scale factor. So we're making our own photo stickers. Cool. Your photo, which is this one, is 4 by 4, 4 inches by 4 inches. The image on the stickers is 1.1 by 1.1. What is the scale factor for the reduction? Okay, so how would you find scale factor? You're going to take the ratio, right?
Yeah.
Okay, so we're going to take the side length of the sticker compared to the original. Well, what's the side length of the sticker?
4 by 4.
The sticker. 4 is the original. The sticker is 1.1.
Yeah.
And then the original is 4. So then basically you just simplify that, because you can't have a decimal in a fraction. So you do 1.1 divided by 4, which would give you what?
1140.
Yep. So that would be your scale factor.
Yeah.
That's it. Just find the ratio and then simplify it. The biggest thing you need to recognize first is it a reduction or an enlargement? Because on a reduction, you're going to put the smaller object on top and the bigger one on bottom. If it's an enlargement, you flip it. So those are your big things you got to remember. That's it. That's the lesson. So you're doing numbers 4 through 30 even.